Hey 8th graders, today we're going to do part 2 of lesson 8.5, which is another factoring process. The factoring process from yesterday was called reverse distribution, just to remind you. So let's rehash what we had talked about and then kick into today's lesson. So remember that factoring is dividing polynomials or anything into its parts. So when you factor, you're breaking things up into their parts. Now, today we're going to work on a process called factoring by parts. Factoring by parts is a combination of distribution across multiple pieces. So distribution across multiple pieces. The factoring by parts process is very specific and planned out, so hopefully it'll go pretty smoothly. It usually is not a huge deal. I just like to separate it from the distribution process. The book likes to kind of group the two together because they both use reverse distribution, but the way factoring by parts uses reverse distribution is significantly different than the way factoring by parts uses reverse distribution. So I think it's important to separate the two when we talk about them. Again, we'll be working with GCFs, which are our greatest common factors. Alright, so I want to go through the factoring by parts process. One of the really nice things about the problems in this chunk is that breaking them apart is not going to be nearly as significant because there's going to be multiple pieces that we're looking at, and so we're not going to look at as complex a situation. The downside is that there's a couple of different processes along the way which might throw some people off. So there's not a real great connection between yesterday and today sometimes, or between the last lesson and this lesson. So up here I have a problem that we're going to work on. I have xy minus 7x plus 7y minus 49. Now, these distribution property factoring by parts problems will always be quadrinomials. So that's your immediate first tip-off. If you see a quadrinomial, it is very likely we're going into factoring by parts. Quadrinomial means 4 pieces. Now, it's not a guarantee that you're doing factoring by parts, but it's almost always going to be factoring by parts. The other key that tips Mr. P off that this is going to be a factoring by parts question is that there are no pieces in common when you look at the factors of this. So xy is already factored, 7x is already factored, 7y is already factored, 49 becomes 7 times 7. There are no common factors between all 4 pieces. That's the other tip-off that tells me that this problem is factoring by parts. The first step to factoring by parts is to split the problem into 2 separate problems right down the middle. I want 2 binomials in the front and 2 binomials in the back. Now, if I'm splitting on a plus sign, that's going to be a big positive because it's going to cause me less issues. If I'm splitting on a negative, there's an extra wrinkle I'm going to have to go through, which we'll deal with when we get to this problem down here and the example that I'm going to do later. Okay? Because I'm splitting out a positive, I don't have to worry about that. I'm going to ignore the first, I'm going to work on the first part, ignore the second part of this problem. So just pretend that this second piece is not even here right now. It disappeared, right? Temporarily. Now I want to look at what the common factor is between these 2 pieces. There won't always be a common factor. If there isn't, we're going to put 1 out in front of the parenthesis, but most of the time there will be.
Jody Freeze, please dial extension 7788, Mr. Basil's office. Jody Freeze, Mr. Basil's office extension. Thank you.
Sorry about that. So, now we have an x in both terms. We're gonna go ahead and take that x and put it in front of the parenthesis, just like we were doing yesterday. There are no other common terms in here, so then we're gonna write down what we have left, y minus 7. Everybody understand how Mr. P got the first half of that problem? Hopefully. Now we're going to look at the back half of the problem. We're going to drop a plus in between because there's a plus here. Now we're just looking at the second part of this. We're going to ignore the first part of it now. And we're going to ask ourselves, what's common in the second part of the problem? Well, they both have 7s. So we're going to go ahead and cross those 7s out, put the 7 in front of the parenthesis. Then inside the parenthesis we write what's left, y minus 7. Now at this point in time, you should have two identical factors, identical binomials on both sides of your problem. If you don't, something probably went wrong. And it's probably because you had a minus sign in between and you've run into an issue. But if it's not, you need to either relook at the problem or ask someone for help. Ask Mr. P for help, ask a friend for help, because at this point in time, if you don't have two identical binomials on both sides of your problem, then we have a problem. All right, there's an issue here. Y minus 7 should be there. Okay? Now, there's a big convoluted reason for this next step, but I just want to do the easy version. We're going to take everything that is not in a parenthesis and group it together in a set of parentheses. So this x, this plus sign, and this 7 are going to go in my first set of parentheses. In my second set of parentheses, I'm going to put the thing that I have on both sides, y minus 7. I don't need two of them, just one of them. This becomes my solution. X plus 7, y minus 7. Let's take a look at this second problem and try to do the same thing. We're going to split the problem into two parts. In the front part, I have 4CDD. Not very good D. And 3CD. I'm looking for commonality. There's a C in both pieces. So I can take that C out. There's a D in both pieces. So I can take that D out. And then I write what I have left. 4D plus 3. Now, in this problem, we're going to have an issue because of the minus in the middle. So right away, what we're going to do, we need to do this immediately before we go any further, is we're going to switch the minus here to a plus. Anytime you have a minus here, you change the sign here. If this was plus, you'll switch it to minus. If it was minus, you'll switch it to plus. Immediately, if you have a minus here, switch the sign here. Don't do anything with this sign, it stays a minus. This sign needs to switch immediately. Now we're going to look for commonality between them. 20 splits up into 4 and 5, and 4 splits up into 2 and 2. So this is 5, 2, 2, D. Over here I have 15, which is 5 and 3. I'm looking for things that are in common. I have a 5 in both terms. So I can take that 5 out front. I do not have 2's in both terms. I do not have D's in both terms. I do not have 3's in both terms, so I have to write what I have. I can clean this up by calling that 2 times 2, which is 4D plus 3. Now you'll see how I ended up with the exact same thing on both sides. If you come across a problem where you end up with a binomial on both sides that looks kind of the same, only your sign ended up differently, you probably missed switching this sign when Mr. P told you to with the negative there. And you just need to go back and fix that. Now we can go ahead and push these together. Remember, in our first parenthesis, we're going to put everything that is not in a parenthesis. C, D, minus 5. In our second parenthesis, we're going to put our common binomial, 4D plus 3. We only need one of them, not two of them. The hesitation for students is to try to write this twice. I only need one of them in my final answer, not two of them. Okay? Does everybody hopefully see what I have going on there? Alright, while I'm over here erasing these terms, hopefully you'll have time to copy that stuff down. There will be, again, an extension extra help problem posted on Schoology for those of you who need it. The homework is on page 524. We're going to finish it off with 21 through 32. Just a little side note, number 28 is material from last lesson. In other words, it's a reverse distribution problem. It is not actually a factoring by parts problem. It just is snuck in between all the other factoring by parts problems. Right now, Mr. P is going to do number 25. Like I said earlier, there'll be an extra problem, number 32, online on Schoology, waiting for you. I did another problem with a minus in between so that we could catch that before it becomes an issue. Let's take a look at what we can do here. 45 splits into 9 and 5, and 9 splits into 3 and 3. So I have 3 times 3 times 5, PQ. 27 splits into 9 and 3, and 9 splits into 3 and 3, so I have 3 times 3 times 3 times Q. Immediately I'm going to switch this sign because this is a negative in the middle. 50 is going to split into 10 and 5, and 10 is going to split into 5 and 2, so I have 5, 5, 2, P. 30 is going to split into 10 and 3, and 10 splits into 5 and 2, so I have 5, 2, 3. Now I'm looking for things that are in common. I have a 3 shared in both of these terms, so I'm going to take that 3 out. I have another 3 shared in both these terms, so I'm also going to take that 3 out. I have a Q in both these terms, so I'm going to go ahead and take that Q out. Then I'm going to write what I have left. 5P minus 3. Minus. Alright, let's take a look at this second guy. I have a 5 in both terms, so I'm going to go ahead and take that 5 out. I have a 2 in both terms, so I'm going to go ahead and take that 2 out. That's all I have common in both terms, so I'm going to write what I have left. which is 5p plus 3. Oh, I wrote my problem wrong the first time. Or 5p, no, I'm right. 5p, oh my gosh, minus 3. Here's Mr. P's mistake. So, I apologize. I knew that I had made a mistake here because I didn't have identical terms. When I switch this from a plus to a minus, I wrote plus again here. Instead of writing the minus, it should have been, so it should have been minus. So, you can see where the mistakes happen at this point in time. Make sure that you have two identical binomials sitting inside here. Now we can clean this up and write it as a whole. Our first parenthesis, everything outside, we can clean it up here. 3 times 3 is 9q minus 5 times 2 is 10. And in my second parenthesis, I have 5p minus 3. Remember that I only need one of those. I don't need two of them to make the problem work. Hopefully that went well for everybody and we understand what we're doing. Make sure to pause this if you need the extra time. And I will see you all very soon.